Good morning, students. I hope all of you understood the last class where we start with congruent triangles and similar triangles, isn't it? So congruent triangles, all of you know in class 9, and here in this class 10 we discuss about similar triangles, actually similar figures. So in our last class we discussed some similar figures. So with related to this we complete our exercise 6.1 also, isn't it? So now today here we start from similarity of triangles. Is it clear? So here we discuss the first point is here similarity. So that means this one we write similarity of triangles. So this one. So similarity of triangles. So in similarity of triangles means what here? First of all, we have to consider two triangles. As you see here, if we consider two triangles, suppose the first triangle is this one, and here which one is we consider A, B, C, suppose. And the another triangle here, if we consider the second triangle is here, this one is D, suppose this one is E, and here it is F. Clear? So the first triangle is here, this one is ABC, and the second one is D, E, F. This one is the triangle. So similarity of triangles, that means here first of all, in case of similarity of triangles, when we say two triangles are similar, so if two triangles are similar, first of all, similarity, all of you know, if the shapes are same but sizes are different, then we can say similar figure. In last class we discussed about. Now here, if two triangles are similar, then what we get from here? So first of all, the corresponding angles are we get equal. In case of similar triangles, we get corresponding angles are equal. So first angle here, angle A, that means this one is D. So first point we write here, angle A is equal with angle D. These two are known as corresponding angle. Similarly, another two angles are here, angle B. So this angle B is equal with angle E. So that's why here we have to write here angle B is equal with angle E. And the third one is here C. This one is the third one, and here the third one is this one, third one. So angle C is equal with angle F. Now you see here angle C is equal with angle F. So that means these three are known as the corresponding angles. So if two triangles are similar, that means first point, their corresponding angles are always equal. So that means A is equal with D, B is equal with E, and C is equal with F. So one more thing here, if two triangles are similar, then their corresponding angles are equal. As well as here one more point we get here, the ratio of their corresponding sides are also equal, the ratio. So that means the first angle A is equal with D, B is equal with E. So that means the ratio of their corresponding sides. So that means what you have to write, AB by DE. So that means in this case we have to write here AB by DE. The ratio of their corresponding sides is equal with the other part. So that means here BC is equal with EF. So that means here we write BC is equal with EF, as well as the third one we have to write here AC is equal with DF. AC is equal with DF. Is it clear? These two are the conditions. So in case of if two triangles are similar, then the ratio of their corresponding sides are equal, and another one is the corresponding angles are also equal. So in case of two similar triangle, we get these two conditions. Now here one more thing here, you see, if the corresponding angles are equal, then there is another name here. If the corresponding angles are equal, then these two triangles are also known as equiangular triangles. Is it clear? Equiangular triangles also we can say here, because why? These two for these two triangles the corresponding angles are here equal. Is it clear? So this one is the condition of similarity of triangles. So if anyone asks you what is the condition we get in case of similar triangles, so that means we have to say, we have to write the corresponding angles are equal, as well as the ratio of their corresponding sides are equal. And with respect to this, if the corresponding angles are equal, then these two triangles are also known as equiangular triangle. Is it clear? So now with respect to this, Now here you see a Greek mathematician gave an important truth between these two similar triangles, or between these two equiangular triangles. Which two are the equiangular triangles? These two. Reason behind, the corresponding angles are here equal. And now here, with respect to these equiangular triangles, that means this great mathematician gave us here what given? The ratio of their corresponding sides are also equal mentioned. Is it clear? So that's why here written the ratio of any two corresponding sides in two equiangular triangle is always same, and this one is given by a Greek mathematician whose name was Thales. Is it clear? Thales. Or that means what here mentioned? Equiangular. Equiangular triangle means, if anyone asks you what is equiangular triangles, that means we have to say here the corresponding angles are equal. That means corresponding angles are, these are the corresponding angles in case of triangles. So Thales gave us what? If the corresponding angles are same, that means these two triangles are known as equiangular triangles, and if we get two equiangular triangles, then the ratio of their corresponding sides are also equal. Is it clear? And which one is given by Thales? Is it clear? So that's why with respect to this, one theorem is here. One theorem is here, and which one is? We write here theorem 6.1. The statement given in your book. Now here, what is the meaning of this statement? Let's see here. In theorem 6.1, this theorem is also known as Thales theorem or basic proportionality theorem. Basic proportionality theorem. Is it clear? This theorem 6.1 known as Thales theorem or basic proportionality theorem. So what is the meaning of this statement? You see here. Suppose here, if we consider a triangle, the triangle is this one, if we consider, suppose. Now here A, here it is B, C. So any one side, with respect to any one side, it may be AB, it may be BC, or it may be AC. Any one side we have to consider. So now here, through, suppose we consider now the side AB. Through this side AB, if we draw a line, through this AB, if we draw a line, and the line parallel to, suppose, this BC. So now here, if we draw a line, suppose this one is the line here we draw, and this line intersect AB and AC at two places, and these two places are, if we denote it by D and if we denote this one by E. Now here you see, if this DE line is parallel to BC, remember this DE line is parallel to BC, and the BC is known here known as the third side, because this line DE intersect AB at D as well as intersect AC at E. So two sides are here gone, and the third side is known as BC. So that means if this DE line parallel to BC, so that means here what we get, DE parallel to BC. This condition required here. If the line parallel to the third side, then from here we get one condition, and the condition is what? Here the ratio of their corresponding sides are always equal. That means what? AD by DB. So if DE is parallel to BC, according to the Thales theorem, what is the formula condition we get here? AD by DB. So AD by DB is equal with AE by EC. Is it clear? This one is the meaning of the theorem 6.1. Is it clear? Practically we get like in this way. So that means in case of a triangle, if a line parallel to the third side, that means the ratio AD by DB is always equal with AE by AC. All of you understood this one? So this one is known as basic proportionality theorem, or it is known as Thales theorem. So now it related to this, another theorem is there, and which one is theorem 6.2. So theorem 6.2 is what? the inverse theorem, or the reverse theorem also we can say, inverse of Thales theorem. So 6.2 is known as inverse of Thales theorem. So in Thales theorem, what we get? If the lines are parallel, then the ratios are equal. Isn't it? In Thales theorem, what we get? If the lines are parallel, then the ratios are equal. And in case of inverse, what we get? If the ratios are equal, inverse, if the ratios are equal, then the lines are parallel. That means in this case, what we get? If the ratios are equal, that means AD by DB is equal with AE by EC. If we get this one, if this one is given to us, so from here what we can say? The line is parallel, the third side, that means DE is parallel to BC. Is it clear? This one is the inverse of Thales theorem. Thales theorem is if the lines are parallel, then the ratios are equal, and the inverse is what? Here, if the ratios are equal, AD by DB is equal to AE by EC, then the lines are parallel. Is it clear? So these two theorems are very important. In our exercise 6.2, these two theorems are we use. Is it clear? Now it related to this 6.1 and 6.2. Let's take an example. Now, if you see this example, suppose if we consider a triangle here, suppose if we consider a triangle, and the triangle is we denoted by A, B, C. Now here the condition is given, this line, suppose this line here we denote this one by D, and this one is we denoted by A. And now here the condition is given, already given, suppose DE is parallel to BC. This condition is given to us, suppose. Now here first of all a triangle we consider, and here this DE is already given parallel to BC, given, suppose this one is given. And now here some results are mentioned. The length of AD is 1.5 centimeter, and now here this one is suppose 3 centimeter, and the length of AE is suppose 1 centimeter. Can you find out the length of EC here? So easily we can find out, as not it. How can we find out here? Because already given D is parallel to BC. If D is parallel to BC, according to our Thales theorem, what we can write? The ratio of their corresponding sides are equal by, what you have to write? By Thales theorem. By Thales theorem, or according to Thales theorem, what we can write here? The ratio of the corresponding sides. So that means here AD by DB. So AD by DB is equal with AE by, so this one we write here AE by AC, isn't it? So according to the Thales theorem, AD by DB is equal to AE by EC. Reason behind, DE is parallel to BC already given to us. So just you have to put the value here. AD means what? AD means 1.5, DB means what? 3. Here you have to put. AE means what? 1 you have to put, and then easily we can find out the value of EC from here. Is it clear? So you have to find out the result and tell me what is the answer here. So in this way easily we can solve different types of questions here. So today here we discuss about the similarity of triangles as well as the Thales theorem. Thales theorem is theorem 6.1, and the reverse one, inverse one also we discussed, which one is as 6.2, isn't it? So in our next class we have to continue this one, and we have to solve some example questions. Is it clear? Okay, thank you.